So now that we know what makes a mineral, let's talk about the ways that we can actually use these properties to identify which mineral we're actually looking at. We are still working with Middle School Earth Science Standard 2-1, which states that you will develop a model to describe the cycling of Earth's material and flow of energy that drives this process. Basically, by the end of this, you should be able to identify minerals based off of their physical properties. We are doing something new with notes this week. There is no whole group versus independent work. I'm going to go through some things, but it is all going to be feed yourself. What is most important that you feel you need to know in order to be as successful as possible on the upcoming lab? So when we talk physical properties, when we talk descriptions, I would advise writing down the steps, how you do it, what the importance is, how reliable this test is, just because it's going to be up to you to kind of figure it out. We are starting to learn some of these skills on what important note-taking looks like versus what just note-taking is. Okay, so here are the different tests. You are going to be going through 7 different tests to be able to identify a potential mineral. Okay, so the test would be color, looking at your Roy G. Biv. So what color does your sample look like? So the difference between this yellow sample and this red sample. Luster, how shiny it is. So whether it is metallic, whether it is kind of creamy, but yet still gives that reflection off, all that. The streak, the color that is left behind when you streak the sample across a porcelain streak plate. Hardness, can it scratch or can it scratch something else? Cleavage and fracture, not just a really silly word, but how do things break? Density, a little matter or a lot of matter that makes up the actual mineral. Oh, excuse me. And then finally, special properties. Does it do something cool? A lot of minerals actually do really cool things. So we are going to talk about one, and then I'm going to set you on your way. So color. This is essentially what color does the mineral look like. So it'll be a simple, when you're doing the actual test itself, you're just going to be looking at the sample and identifying Roy G. Biv, like what color does it truly appear to be like. Now, 2 minerals can be the same color. So like I can sit here, I can take out my halite and my quartz, and they're both clear minerals. Okay? So what I'm trying to say with that is that this isn't the most reliable test. So to determine, like, what determines the actual color of a sample? Well, chemical makeup. Okay, silica quartz tends to be clear, but then if you have impurities within it, then it starts turning different colors. So my sample of quartz is either going to be clear quartz like this or milky quartz, where it looks a little more, if you look down at this picture, kind of that middle portion, that would be like a milky quartz. But because of the impurities, quartz can turn towards amethyst, so purple, or rose quartz, which is pink, or a citrine, which is orange, or you have like a combination of a quartz countertop, or you get really pretty quartz with mica muscovite. Gorgeous. But color is probably the least reliable, but it at least kind of gives you a starting point. What should you be looking at? That sort of a thing. Okay, so that's all I have as far as whole group. So if you are done with whole group and you're going to go do the other sorts of testing and whatnot, or note-taking, not testing, my brain's everywhere, then this is your time to go. If you are joining me for whole or for independent group, let's get going. So when I think of luster, there's really only one other word that comes to mind. And that's shiny. And not just because like Moana was our quarantine movie, But because Tomatoa honestly puts it the best way, luster is how shiny something is. Now, there are two main categories of luster, whether it is metallic luster or non-metallic luster. So metallic luster literally is, does the sample look like it's a piece of metal? Goodness, I don't know why I can never line this up. Does it look like a piece of metal? Okay, so that this would be another, okay, so that. Then you have non-metallic. So this would be something that is brilliant, like a diamond. This is something that could look kind of waxy. Why do I not have talc? I don't have talc in this sample. I'm going to pause for a second. I say I'm going to pause, and it makes no difference to you guys because I pause it and then it starts right back up here. Anyway, I had to run in the back and get a piece of talc. So talc can look kind of waxy or kind of silky-ish. But when we say silky, we're looking at things like, can't really see it well on this one, but it looks like little strings of silk, pearly. If you think of a mother of pearl, again, I have another example on my ring that I don't think you'll be able to see. And then vitreous, basically, does it look like a mirror or does it look like a piece of glass? Things like that. I'm going to give a couple more examples here on the next slide, but that is the difference between whether your luster is metallic or non-metallic. So when we're talking non-metallic, we are talking about a bunch of kind of different looking things. So if we're thinking brilliant, we're thinking a diamond. Like, you imagine how a diamond shines when the light is like shown on it. That would be brilliant. You're not really going to have any of those because the school budget for diamonds was really, really low this year. So we don't have diamonds available to you, but if you want to take a peek, I can see if my ring would show brilliantly. We'll see. Waxy or greasy, oily, that would be like our sulfur. So to where it almost looks a little fake, like I feel like our sulfur looks super plasticky, but kind of waxy, greasy. Silky or fibrous, whereas my galena, or my gypsum, sorry. So this little example, it looks like it has individual fibers. I will hopefully bring in my selenite, and that I feel like shows silkiness a little bit better. Pearly or creamy, that is my talc. If you kind of put your hands on talc, it looks creamy, it feels, I'm not even showing you the pictures. So that is gypsum, you can kind of see the lines in it. Talc is that creamy pearly, and then finally vitreous or glassy, that would be our quartz, where you could kind of sort of see through it. Halite would fall under the same thing, and calcite, wherever my calcite sample is. This was a really bad box to grab, apparently. Streak. So this is the color that the mineral leaves in its powder. Okay, so no matter the color of the mineral, it will leave the same color like streak. So whether you take a piece of rose quartz versus citrine versus amethyst, they're all going to leave the same streak. So if you take a peek though here at this picture, this is why I involved it. So you'll see that this sample here on the far left-hand side didn't leave any streak. This one left a really burnt red one, this one kind of brown, and then this one left a gray, this one left a white one. Okay, those were important because all of those samples look the same, but you can tell because of the streak that it's something different. Now, the way that we perform a streak test is you will have one of these porcelain streak plates. They're very, very thin, okay, a little bit thicker than a piece of paper. Okay, you will firmly grasp one of your samples in your hand and gently grasp the streak plate in the other, and then you're just gently going to go across. Now, this one should have left a yellow one. I don't like this sample. Okay, But then you are going to streak across and you're going to try to figure out, and yes, they are dirty as you know what, but you should be able to see where you struck, or remember generally where you struck, and then look at what color was left behind. Okay, if your streak plate is absolutely disgusting, please come talk to your teacher and we will make sure that it gets replaced with a clean new one. Okay, but be very, very careful. If anything's going to break, it's going to be this porcelain streak plate. Just let your teacher know and we'll get it cleaned up. Not a big deal. Okay, so that is the streak test. It is actually very reliable if you're streaking correctly and you know what you're looking for. Hardness. This one is interesting. So we use a scale called the Mohs hardness scale to be able to identify the hardness of different minerals. We have it ranked on a system of 1 through 10, 1 being the softest, 10 being the hardest. So it's a scale that compares the hardness of different minerals and their resistance to being scratched. So obviously something low like 1, 2, 3, they're scratched very, very easily, versus 8, 9, 10, they scratch very well on other things, but they do not become scratched themselves very easily. Now, there's a couple of different tools that we use for this test. A lot will be with just what you have readily available to you, but they all should be in your mineral boxes. So, the first one would be your fingernail. And if you have acrylics on, I don't recommend you doing this test, but anyone else, you simply just take your fingernail and you scratch, and then you look under the fingernail and see if you have any residue. Now, there are going to be some where when you scratch at it, it's going to leave a little something, but it's actually flaking away, it's not scratching. So you need to look and make sure that you are leaving a mark on your sample. Okay, so talc can be easily scratched, gypsum can be easily scratched, and kind of sort of your muscovites. Then you will have your copper penny. Okay, please don't take the penny. It's a penny. Okay, so you take that and then you firmly hold it in between you use your pincers, okay, your index finger and your thumb, and then you go and you scratch and you see if you have left a mark where you scratched, or you could potentially see some like residue left on the edge. That's the copper penny. Iron nail. Remember, a nail is flat and then no ridges. Okay, so your iron nail, please be careful. I hate that I have to say these things. Okay, but again, firmly grasp your sample, take the nail and scratch across and see if you can see a line that you left. Okay. Glass. You have a glass streak plate. You can see this one's really scratched up, and that's because people kept taking my quartz and scratching it. Quartz is very, very strong. Quartz has like an 8 or 9. Please don't scratch my scratch plates with it. Okay, this is meant to scratch the item. Okay, so fluorite. Okay, I should be able to see a mark where it actually scratched. Yes, if you're like, I don't know whether it scratched it or I scratched that, if I do that, oh, it left a mark. Okay, just a little one, don't scratch it all to hooligans. And then finally a steel file. We don't have a steel file, but we do have steel screws. Okay, the difference is iron is much, much softer than steel is. So then you should be able to take this and really leave a possible mark on your more strong. I recommend starting from the bottom. Start with the fingernail and work your way up as you progress through. There are going to be some where you're like, well, it could have been the penny, it could have been the like iron nail. If you get stuck, ask your teacher. We will come around and we will help guide you a little bit easier. Or if you're completely off, we'll tell you you're completely off. Okay. But biggest thing is be very, very careful. You don't need scratched up hands and whatnot. Just please don't. What is the difference between cleavage and fracture? So yes, I'm going to give you a moment. Cleavage is a really funny word, especially when you think we're talking minerals and not what you're actually thinking. Okay, have your moment. Sweet, moving on. So cleavage, this is where a mineral breaks or splits apart with a flat surface. So I don't know if you'll be able to see this, but you can kind of see that, like, oh, it's on the side here. You can see how it has this one little jut out, like it was a piece of Lego. That is what cleavage is. It's where it splits and it still keeps a form. Versus a fracture, this fractured. There's no rhyme or reason to why this mineral split the way that it split. It just did. Okay, so a fracture is when a mineral breaks apart with rough, jagged, irregular shapes. I'm going to give you a couple more examples. So cleavage, this is where you get these really nice like shapes being pulled off. You get cubes pulled off. Amethyst in quartz is a really great example of it, okay, because this is a rough cut of amethyst. But you can see here muscovite is in sheets. You have feldspar that is in two directions. You have halite, which are these cute little cubes. And then you have calcite, which are these little rhombi, something like that. Okay, they form that way. If you look at most of them, they will be shaped that way. None of these samples in your boxes have been polished or cut in any like rhyme or reason. They're just samples. Okay, so if they look like they have an actual shape to them, it's because they have an actual cleavage break instead of a fracture break. So fractures, this is just where they break unevenly. Okay, there's no rhyme or reason. It looks like a legit rock. It's just what it is. Okay, so that's the difference between cleavage and fracture. I don't choose the words. I would never choose that for 8th graders, but that's just me. Density. Now, this is something that we haven't figured out a way for 8th graders to actually perform safely. So basically what density is it just measures how much matter there is in a given area. So if you were to have 1 cubic centimeter of each of these minerals, the density is that physical, like there's more mass to them. The denser the substance, the heavier it almost feels, just because you're jam packing so much more into the same basic area. Okay, so density does not depend on the amount of the matter of the substance. It's just what is packed in those really tight corners. Okay. This is something that would be almost 100% accurate in being able to help identify your minerals, because physical properties can be measured without changing the substance chemical identity. All of their densities are 100% set with the types of chemicals that they were or they are, and all of this. It's just what it is. But should you be able to kind of sit here and feel like, because these are roughly the same size, can you feel the slight difference? Yeah, quartz is a little bit heavier than halite is, okay? But you're not going to be able to do an actual density test here within the school setting, but just so you know, it is an option outside of school settings. Finally, special properties. So special properties will be coming around and kind of showing you some of these. So this is a simple magnet. And what you can honestly do is if you run it across, where is that one? Dude, here it is. Okay, so you will be able to actually see the magnetic. I'm honestly, okay, you'll be able to see that. So some are magnetic. Some are fluorescent. So if you look at the picture, like right above my head, the dull colored ones, those are the regular minerals. But then if you place them under a UV light, they do change colors to fun fluorescent colors. Taste test, do not do not lick my mineral samples. Do you know how many grubby middle school hands have been on this? Don't lick it. But you saw me in the last video smell. You can smell this little one, and it smells salty, okay? Because I know it's halite. It smells salty. Versus, and like I said, can't find my calcite, but calcite looks very similar, but it doesn't smell or taste like salt, but rather it reacts to hydrochloric acid. So we will come around, we will show you the cool little like reaction that happens. It's super diluted hydrochloric acid. But yeah, so special properties are just these cool things that minerals can do without really doing anything else. So this is why, oh my goodness, now I can't think of the name of the things, but there are specific like lake rocks and ocean rocks that come up and they fluoresce, and that is because of these minerals. So yeah, that's kind of what's up. Hopefully you have a better idea. We'll go through some of these tests again before the actual lab, but I wanted to make sure you had a good understanding of it before I set you free. So awesome. Make sure you complete your check-in and get your notes done and turned in. And I think that's it. Awesome. Thank you, everyone.